Hello, in this video, we will introduce minimum spanning tree. A minimum spanning tree of a graph is a spanning tree with the minimum total weights. Let's look at this graph. The graph may have all kinds of spanning trees, many of these spanning trees. So we need to find the minimum ones. So let's look at this. B is a spanning tree. What's the total weight? It is 42. So here C is a spanning tree. The total weight is 38. Now, if you look at all possibilities, you find out that this is a minimum spanning tree. And the minimum spanning tree is not unique. Here's another one. All we need is to find just one minimum spanning tree. So here is the algorithm. We're going to use the Prim's algorithm. It works as follows. So we are going to have this is the minimum spanning tree returns an object of the minimum spanning tree. So let T be a set for the vertices in the spanning tree. We're going to set the cost of V to infinity for each vertex V. Pick an arbitrary vertex, say S, as the starting one, and set the cost of S to 0, and the parent of S is now -1. While the size of T is less than n, we're going to find the u not in T with the smallest cost u, add u to T. And now for each neighbor of u, this is the neighbor of u that's not in T. And so this is V here. We're going to check if the cost of V is greater than this h from u to V, update the cost, and reset the parent of V to U. So this is a greedy algorithm. Every time we're going to pick the smallest cost for that vertex, we're going to add it into the spanning tree. So let's look at this algorithm here. It's this is how it works now. Initially, this is T is empty. So now we'll keep adding it into T. So for example, now this is the vertex Y. Among all this vertex, and Y has the lowest cost. So we're going to add Y to T. After you add Y to T, you're going to adjust the cost for the neighbors of Y in V minus T. So let's look at this example here. We have, this is the graph, and here's the cost. Initially, this 0 is 0, and all of this infinity. So we're going to add now 0 is the smallest cost, add it to T. So then adjust the neighbors of 0. The cost for 1 is 6, for 5 is 5. Now we're going to pick 5. The cost is 5. So we're going to pick this. So 5 is added, and now adjust the cost for this 1, 6, 4. As 1 remains 6, and this is the smallest, and 6 is now 7, and 4 is 12. And next, we're going to pick the smallest one, which is 1. So after that, you're going to adjust 5, 6, 2. So now 5 is still, 5 is already in the tree, so we're going to adjust the 6, 2. So for 2 is 10, and 6 is still 7. This is no change. So now let's look at the D now. And this is, we're going to pick the smallest one here. Which one is the smallest? The smallest one is for the 6 is, this is 7, and the parent is this 5 here. And after this, adjust the cost for 2. It was 10, so now it becomes 5. And adjust the cost for 4 was 12, now it's 7. So pick the smallest one here, I pick 2, so 2 is here now, and adjust the cost, and for 3, and so this 4 is still 7. Now pick the smallest one is 4, so now the next one is 4. Now after that, so we're gonna pick what is left is 3 here, this is the edge here, and that is how the minimum spanning tree algorithm works. So the minimum spanning tree algorithm returns the minimum spanning tree, which is subtype of tree. So in this minimum spanning tree, we have the total weight, and this is the constructor, and here you get the total weight. So here is minimum spanning tree. It is a subtype of tree. So you're gonna get the constructor, and this is the get total weight, is simply return total weight. So the minimum spanning tree algorithm was implemented in this listing 27.2. So this is listing 27.2. It's right here. So let's look at this. This is the one right here, get minimum spanning tree. So we're gonna get the minimum spanning tree starting from vertex with index 0. So using this, T is a vector, and this is the parent. So this parent starting vertex is -1, and total weight is 0. And here is the get cost. Initially, everything is infinity except the starting vertex. And now expanded the T, and this is a while loop. We're gonna find the smallest cost. So find the smallest cost, it's right here. Find the smallest cost. And now this is, you're gonna find all this, the minimum here. So then you push this to T, and here adjust the cost for the neighbors, which are not in T yet. So this is the implementation for minimum spanning tree. And this is a test program using minimum spanning tree with all of this. And here is the, we create a graph. So this one here, vertices and edges, and here is number of edges. And we create a graph 1. So we're gonna get that the tree is graph 1 dot get minimum spanning tree. So then, so what is the total weight? And this is tree 1 dot get total weight. So print the tree. This is to print the tree. And print the tree, this is the function here, print the tree. That is all for this section on minimum spanning tree. See you on the next video.